So you want to take your visual processing skill to the next level. And that's exactly what me, jit.gen and jit.gl.gen are here to do. So if you're unfamiliar, this is Dozer, my favourite movie in the world, after maybe Red Ball. And we've made this little patch so we can play about with the colours in it, which is pretty wild. And if you've been watching my past videos, you know I'm really interested in video manipulation for this sort of thing. We're just going to throw a kaleidoscope in there with some axis offset. We can get really trippy really quickly, and that's exactly what I want. The end goal is to eventually attach this to a music track, so it's all automated and it's all going to beat against different levels, but that's going to come over the next few tutorials. Over the next few weeks we're going to start looking at how we can start bringing all this together to make our visual noise based installation. So let me just turn that off and let's have a look at our actual patch. So it looks fairly basic, but that's because all the work is being done by these here, or just one of them at a time. jit.gl.pix and jit.pix are part of the jit.gen system, which use MOP objects. And the easiest way I can describe what jit.gen and jit.pix do is it's like jitter on drugs. So the way things work inside a gen object is, rather than processing it, say, frame by frame, everything is treated as a clump of pixels. It all happens synchronously. Everything happens at the exact same time, which means that you don't need to worry about this whole method of banging. And now I should just add a precursor here that there's going to be a lot of colors multiplied on top of each other, so we may never get the desired image we want, or we may not be able to return to normal image. Much like with normal Macs, we can still pass parameters in and about, but what happens is that we need to pass in these things called parameters. So when we pass in a message that's pack colors here, inside of my gen message, it's going to be looking for a parameter called colors. We're getting closer to actual programming here than we are just joining objects together. The reason I have jit.pix is that jit.pix is the exact same as jit.gen, but for dealing with 2D objects or 2D planes, whereas jit.gen is like the full bundle dealing with full 3D images and operations, which I don't need to get into at the moment because I just want to work on a 2D plane. Why am I using it? Because it's really good. Imagine jit.pix is like a jit.gl.slab. If you look at my first video, I'll link it somewhere over here. Slab on acid. It's just much more complex. It's got much more CPU power behind it, and more importantly, we can now offload it onto the GPU. So before we get into the actual tutorial, that's what we're going to look at here. So jit.gl.pix, when it says gen, that just is the name of the object I've got, so it links to my window properly. This is running off my graphic card, so I can still type things normally. Everything is really reactive, I should say. Whereas if I disconnect that and plug in pix.gen, which has the exact same internals, but is now running off my CPU, when you type, you'll see that everything gets bogged down. And I have the top of the line CPU that I can get, and still it struggles with basic operation. So if you're doing any sort of heavy video manipulation, jit.gl is the way to go from here on in. So the actual tutorial, what we're going to be making today is in two parts. We're going to be looking at a way to mirror our image into this kaleidoscope pattern and then add the offset, and then we're also going to look at how we can alter colors using cosine waves. These are going to be taken from the great Gen tutorials by Gregory Taylor, who works for Cycling74. Go and check that out if you want more help than I'm giving you. I'm going to turn that off, and we're going to start our new Max window. And we're going to save it as jit.pix tutorial. And as always, we're going to start with our toggle and our metro. Just our standard now. I'm just going to go with 30 here. We just need to keep refreshing because we need to refresh a window. And then I'm going to go into a jit.qt.movie, and I'm going to read dozer.mov. You can plug straight into your webcam here and do it with live video, which is really, really cool, but I am in no state to appear on camera right now. Instead of that, let's just check it's working. So I am eventually going to use a GL object, so I'm going to set that up now. So I'm going to have my jit.gl.render, and I'm going to go send it to Gen 1. We are going to need a jit.gl.video plane. I'm going to set the transform reset to 2. Again, give it it's the right definer. Finally, I'm going to do jit.window gen 1 at floating 1. That's why it's not working. Floating. Now will always appear above what we're working on. And yet, it's telling me in my Mac's console that float is not correct. Because we're using gl.render, we need to add a bang erase message to our window, just so we don't get the same image bogged on top of itself. So we put our bang and our erase into the first inlet on the rendered node. And there we go. I'm just going to upscale this a bit, so I'm going to do it at 640 by 480, just so it's a slightly higher resolution movie. So there we go. We have a video playing in a window. We're all big successes. All the real magic is going to happen in jit.gl.pix, where you can see generates pixel processing shaders from a patcher. And I'm going to call it Gen 1. So there isn't actually any calculation happening here, just the default setup. So if you double click it, like you would to open a separate patcher window, you can see here that it's just adding 2 video trains together. So if you do it on top of each other, it gets really bright because it's multiplying alpha as well. But I digress. I've ruined it now. Oh well, we'll just have to live with that until we start processing it. Here we go. So how does it work? It works almost the exact same as another patcher. We set inlets, we set outlets, but there is no need for bangs. It's just a much more dynamic way of processing video, much like with jitter, or when we did with slab originally. What we're going to do is we're first going to start with the color, because it's much easier. I'm not going to need a second input because we're only going to manipulate one video. But in the color control, what we're going to do is we're going to take our video input and we're going to add a multiplier to it. And that multiplier is going to be the parameter that we bring in externally, which is color. I'm going to bring in 3 parameters at the same time. So now, jit.gl.pix to operate is going to be looking for a parameter called color being passed into the first inlet. Now I've put 3.14, 3.14, 3.14 because inside here everything works really well with cosine, sine, just trigonometry in that way. Everything works on a scale of 0 to 1 because they run on what's called vectors. We don't really need to understand why, but it's just everything runs between 0 and 1 and in complete circles. So with those multiplied together, which is still nothing yet, we're going to put a cosine into it. So now if you just imagine that a little wavy graph going above and below zero, and we know that our input needs to be above 0, it needs to be between 0 and 1. Now if we plug it in, it will output a video that is altered by these values here. So our input is timed by 3.14, 3.14, 3.14. And the reason that this is working fine, but if we were to start changing these parameters really heavily without having some extra code here, our colors wouldn't be quite what we expect them to be. So we know that cosine outputs numbers between 1 and -1. So what we times it by 5 and add it by 0.5 just to make sure that we get the color numbers we expect. And you'll run into this if you do any sort of work with Swatch outside of Gen, where you run with float values rather than generic 0 to 255, and already we're getting a fun effect. But even more so, we can now pass in our colors and start manipulating it. And as simple as that, all I'm doing is sending in a message with colors followed by 3 values. So we have control over the RGB color controls on cosine wave. So everything, as I've said, runs between 0 and 1. But gl.pix and gen are really smart and will automatically wrap around. So where it says 1, it's actually just 0.24, and this is just 0.8, and this is 4. But because we're multiplying our input method, it does start to have a more adverse effect, and you'll see that we get more noise, more grain. It just creates a much computerized images the higher up we get, which can be a really nice effect as well, because it's just being multiplied by 32 times, then by 0.4. So it's just something to bear in mind when we automate it, that it might be an issue. And there we go, we've got some quick manipulation over our colors. But what happens if I don't actually want to see it and I want to go back to the original movie? Well, we can do something called question mark, which is a conditional ternary operator. And essentially this is going to work like a gate. So depending on the condition we put into it will depend on which of these outputs gets sent. We can input this into here and it flows through because currently our operator is false. And we can put our image in there. And then all we need to do is add another parameter. I'm going to go color mode because do I want color mode enabled or disabled? I'm going to have a message $1. I'm going to have a toggle, and because it works on a false positive rather than a positive false, I'm going to invert my input just so it displays right. And there we go. So now when it's enabled, it's processing the color, and when it's disabled, it's not processing the color for us. Perfect. And when we look at that in this method here, so when this is on, it's using the, let me just get this card out of the way. So when this is on, it's using our false one because we've inverted it, and when it's off, it's using our true one, which is just our straight input going to the output. Right. And that's our color control done. Quick and simple. Let me half this because we don't actually need it. I'm just using it for the Max console. Is still really handy to have up. Is that we're going to pass our image through. We're going to then have an X reflection, an XY reflection, and then finally a Y reflection on its own. What we're going to do is we're going to bring in norm. And what this is a normalization of coordinates for all our pixel data. And all that means is it's turning it into a value between 0 and 1 so that our gen object can handle it. Because we know that numbers must be between 0 and 1. Much like when we worked with slab in the earlier tutorial, we need to make sure that we're getting all the values for the pixels above and below when we overlap these images. And to do that, we use sample, and that sample's a matrix outside of the current frame we're working in. And I've just added the bound mode mirror so that when we start manipulating its X and Y position, that it will automatically fold over onto itself. We're going to put our actual image into the inlet, and we're going to add the normalized coordinates plus the 2 parameters that we set up for our offset, which will just be X and Y. And this is one of the main benefits we get from working inside Gen, is that we can pass these coordinates as a bulk without having to split our x into y into 2 like we normally would have. We can just do it all in one. So I pass that in there, I pass that in there. So I've got my normal, my parameter offset, and then I'm just going to add that sample straight into our output there. And I'm going to delete the original one coming down. So has anything changed? No, which is a good thing. So that means that we're currently running off our sample, off our mirror controls. Let's pass in our offset parameter. So like with colors, I'm just going to pack an offset, 2 floats. So now when we manipulate it, you'll see that it mirrors itself when we cross over the boundary. That's exactly what we want. So that is our base image. Now let's do some actual kaleidoscoping. So I'm going to bring my parameters up here and leave my norm up there, and I'm going to copy this. Again, I'm going to bring down my original image, but this time instead of just bringing down my parameter addition, we're going to add some mass. So we know we're working with x and y, which is what these figures are. What we're going to do is we're going to do our -1 and -1. And this is going to be our mirror of x and y. So simply by turning the two values negative, it means that we're flipping the image that we're getting in around. And the reason we do it to these ones is because we have control over it. And we know that the gen sample is automatically going to mirror it around for us. So all we need to do is have the negative number, and it will be invert. It will be the inverse. It will be the mirror of our x and y. And then what I'm going to do, so now we have our x and y coordinates being updated. So both going to our output and both scaled, they're there, they're mirrored, but their alpha channels are being multiplied as well. So to fix this, we're going to add a fold object, which folds input to range within a low and high output value, which doesn't sound like much, but what this is going to do, when we input just our x and our y, is it's automatically going to assume, the fold object does here, is it adds all 4 of these together, and then multiplies the color values so they should still be in the... Now the reason we're seeing inverted colors is because we have our x and y, we have our 2 mirrored images on top of each other, and we're adding the inverse so that it now becomes a negative rather than a positive. If we were to add the inverse of our image, so I'm just doing a negative, a logic negator, if we were to plug this in, everything would start looking normal again, apart from where it overlaps, where it would suddenly become the negative. But I kind of like the way it looks, so we'll leave it like that. And there we go, we're kaleidoscoping. Again, the same here, this will automatically wrap around when you go into a float, so 40 is just 0.8 in this case, because we've set it to mirror mode. So I'm going to do the same as I did down here. We're going to add a mirror mode, but instead of color, we're going to call it mirror. And that's going to be what plugs into here. We no longer need that, and it's going to plug to there. And then we just bypass that there. So with mirror off and color off, we have just our base image playing. We can turn mirror on, or we can turn our color mode on, and we can start playing with it. Say we had mirror mode off, and then we wanted to just use the color mode. We need to add our invert logic again, just to make sure that we're getting the desired results. And we can start getting some pretty crazy results just by typing in some random values.